It is now the 4th day of December. Welcome to Advent Code Day 4. I mean, it's not for me. You know, it's still 9 p.m. the previous day for me, but that's all right. We take these as they come. As usual, I'm not really in a hurry to start. You know, since the server's all busy and stuff. And also, like, I don't know. I'm still not really sure how to do streaming, I guess I would say. Like, you know, on Twitch, you obviously want to like start and then have like a kind of waiting room for a bit so people can kind of filter in. But like on YouTube, I announce it ahead of time, so like if you're late, it's your fault. I don't know, not really, of course. But then like it's a bad replay if we just sit around chatting with nobody for a while. Hey, Mark. Not chatting with nobody, but like, right? You know, I got like 9 viewers at the same time while this video was streaming yesterday, or while yesterday's video was streaming, but then like 250 are watching it. So I still feel like in some sense I should optimize for the replay, but if that was what I was going to do, I just wouldn't stream. So I don't know. I still don't know like how much time to kind of screw around at the beginning. What I should do is like start the video at like 8:55 or something, but I don't know. I was having a snack, so I didn't do that. And you know, by golly, there's someone who is prompt, punctual. That's Mark. Okay. Well, I don't know. Whatever. We'll just start. Right? Yeah. Anyone who gets here later, whatever. You're probably gonna already know what the puzzle is. Showed up late because you're doing it. Excuse me. Day 4. Giant squid. You're almost a mile below the surface of the ocean, already so deep that you can't see any sunlight. We're gonna get awfully deep this year, huh? However, what you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. The submarine has a bingo system to help passengers pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. For example, yes, very good. After the first 5 numbers are drawn, okay, there's 3 boards. There are no winners, but the boards are marked as follows. Yes, so 7, 4, 9. Okay, we mark the boards. After the next, yeah, okay, so we're playing bingo. I get it. The third board wins because there's at least one complete row or column of marked numbers. Okay. The score of the winning board. The score can be calculated finding the sum of all unmarked numbers on that board. Multiply that sum by the number that was just called when the board won. And we're not counting the board. Okay, so 24. Okay. All right. I mean, this is a more challenging task than previous days, I think. It's not, like, insane or anything. But there's kind of a lot of simulation and stepping of stuff to do. What is, like, the right data structure for this? I'm sort of torn between an array and just like a list of lists. a list of lists would make it inefficient to like seek out a particular number and cross it off, but you can just like map a function over the whole board that's like, if your number is 21, then erase yourself, right? And to look for rows that are crossed out and columns that are crossed out, you don't really need an array either, right? You can just like look at all the rows, then transpose the matrix and look at all the rows again, right? So you don't really need any random access. You know, if you wanted to be really efficient, you would use an array, and like you wouldn't do any searching. You would also keep on the side a map from number to position, so you could look up a number and mark it efficiently. Oh, also, here's something interesting. You don't actually have to search the entire board when you mark a number, right? When I mark off 23, there's only two ways this could lead to a win, and that's if all the row that 23 is in was already all but marked off, and if the column was all but marked off. But I don't think we need any of that optimization, right? Seems pretty clear. Let me look at my input real quick. I mean, there's a fair number of boards, but not that many, really, right? You know, and how many? There's 100 numbers. Yeah, we don't have to work at all on optimization here. Okay. I think we'll just use a list of lists. We'll probably define a new type wrapper for it so that we can give it a better functor instance, but that'll be the idea. One thing I want to look up real quick. Let me briefly hide my browser window while I do some searching. One never knows, right? I want to look at text regex applicative, which is what I think. Oh. No, this is the wrong thing. Regex applicative. There we go. So I believe that the input format that we have is, oh, by the way, I closed my input? Oops, I need it open so I can download it. I believe this format is regular. So you should be able to write a regex parser to just process. You can write a single regex that like reads this entire thing for you, which should be interesting. And so I want to look at PI here. I forget, does it have like between or something, or set by? Any of the stuff I'm used to from parsec? What's here? Do we have co-map, really? Huh. Hadn't thought about that, but okay. Map the string, I see. Okay. Match. Okay, so where are all my like combinators though? These are just numbers. Like it's clearly all in this package. They point out a few things you can use. Oh, what is filterable? I don't know. I don't need it. That may be, cat may be. Okay, yeah, not interested. They have piece, him, string. I mean, few, 0 or more, but as few as possible. Okay. All right. I mean, I guess you just kind of build this shit yourself, huh? Fine. The only things I mainly need to remember are sim and psim. Msim? Turn a computed value instead of the original symbol. Interesting. Hey, it seems like it would be easy to build msim out of psim, but fine, sure. Oh, any sim. Yeah, okay. Okay, well, let's just start playing around. It'll be a fun parser to write, I think. I'm sure it would be perfectly simple in the language. I forgot how to turn off the damn breadcrumb. How do I turn this off? There we go. I actually do want applicative do today. Probably. We have to define a few types here. Let's first say new type board is a list, sorry, board wrapping a list of int. I mean, we could, wait a minute. Do I want ints? I kind of want, I mean, I do, right? But if I do this, I can derive functor, which I will want, I think. Oh yeah, of course, I don't want ints, because I want like maybe ints, because so I can mark the board off. Yeah, okay, cool. Right, you can put commas here. So if you had like a list of int, for example, and you called fmap on it, you would be like, it would be a function that takes list of int. It would take an entire list at a time, whereas we just want a single item at a time. Now, I don't know. Obviously, an array is like more truthful because our lists are of exactly size 5. I wonder if it's insane to define a new type that's like a 5 of A, and then our board is a 5 of 5 of A. Is that crazy? It's a little, I don't know. I think it's the most honest thing to do. But it would be such a pain, wouldn't it? I don't know, how would you... What would transpose for such a thing look like? Because that's the only hard part, I feel like, right? Let's try that. Let's be a little bit more honest today, shall we? So data 5 of A is 5 of A. Deriving functor, right? And if our board then, will be a board of 5 A's. So that's like reasonably cool. And we could write applicative instances. Like, I'm not sure what is transpose here? Is transpose just traversable? Is my 5 traversable? I don't know. It seems like it should be, right? Or it's at least applicative. All right, what is the type of sequence A? Yes, it wants a traversable. If f and t were both 5, this would be a function that flips. That like turns a board inside out. Obviously, I know, I've mentioned before, this would be way easier if we just used a list of lists, but this is interesting. Or even an array. So obviously I can derive foldable, but I don't really need it. Tell me about traversable. What do you get to assume when you're defining traversable? Minimal is traverse or sequence A. Okay. But if T is foldable, T has to be foldable in order to be traversable. And so you have to write like sequence A basically. It says I have a 5 of FA, where F is some applicative. Could I make an F of 5A using that? It seems like I ought to be able to, right? Let's give it a try. It should be interesting. So forget this board for now. I don't know. I guess we'll want it in a minute, so why not? So give me also, please, derive foldable. Foldable functor. Wait, yeah, you can derive functor. Of course you can. What am I talking about? And we'll probably want some more things in a minute. But let's write instance applicative 5 where this is pretty simple, right? Pure x is 5 of, there are just going to be 5 x's. So that's how you lift a normal boring value into a 5 value. You just repeat it 5 times. This is like a zippy applicative. And 5, oh gosh, this is going to be quite a thing, isn't it? FA, FB, FC, FD, FE, app 5 of A, B, C, D, E is just 5 of FA, no, FAA, FBB, FCC, FDD, FED. So this is an applicative instance that compiles. Good. And you can already do some sort of cool stuff with this. But the interesting thing is, can we write a traversable instance? That would be very exciting for me, I think, because I can't remember a time I've ever written a traversable instance myself. Instance traversable 5 where sequence A of 5. Okay, what's the type of sequence A again? Okay, it takes, well, of course, it takes my T is the traversable, so it takes a 5 of FA and produces an F of 5A. So we'll just call these FBFC, FDFE equals. Yeah, of course I can do this. What am I worried about? So that's 5 of FA, FB, FC, FD, and FE. Is that correct? Yeah, of course. So easy. Which means that we can now transpose a 5 of 5 using sequence A. So this is like, I guess, some complicated stuff if you're not familiar with Haskell. Like, what have we done here? Let's briefly review. This definition of 5 is, you know, it may seem somewhat, what is the word I'm thinking of? Pedantic, maybe? But it's nice to have types that directly reflect what the types they can hold, right? If you build a list of lists, then it can have like more than 5 in a row, or less than 5, or rows that are not the same length. Whereas if we build a structure that can hold exactly 25 things, once we have one of those, we can be guaranteed it will never have an out-of-bounds index or whatever. And so what I'm saying is that to have 5 of something is to have a constructor named 5 and then 5 of that thing. Right? Pretty simple. And we're also giving it a functor instance and foldable, so that we can say, like, for example, did I give this a show instance? I should, so that we can just see it in the REPL here. Compile, please. Okay. So we can say, like, you know, fmap +1 over 5 of 1, 2, 3, 7, 10, for example. And it warns me that it's defaulting to int because I didn't say what kind of number I want, but fine. And we get 5 of 2, 3, 4, 8, 11, as we wanted. And kind of the purpose of making this applicative was, I don't know, it could have been useful. But then in particular, it is useful because I want to be able to traverse such a thing. So I can have Why am I allowed to undo that shit? Okay, anyway. So say I have... Oh, what have I done? Say I have this 5. Let f equal 5 of this in... let's say I wanted to have 5 f. So I want this very same row. Let's say that my this 1, 2, 3, 7, 10 is a row. And I want 5 of those to be... I want to just repeat... I want my board to be that 5 times. And indeed, that's what we have. So now we can do something kind of interesting. We can say let this be row. And let board equal this in sequence a board. What happened? Why are you upset? Variable not in scope f. Oh, I wrote f multiple times. Okay. I changed this from f to row your boat. And you can see it's traversed the board and kind of transposed it in the same way you could transpose a list of lists. We can now transpose a 5 of 5s. We're now looking at like our rows are first the row that was the kind of column of 1s, and then the row that's a column of 2s, and so on. And you can do more stuff with this, like you can turn a 5 of lists into a list of 5s, and vice versa, which is pretty cool. I don't anticipate that we'll need those today, but this is a cool place to start, I think. So, I think what we want to do, now that we have like the main type we're going to be using, is... Well, I guess I didn't actually explain at all what applicative and traversable are. I just said why I wanted them. So applicative is like... Okay, so functor is something you can map over. And we just derived functor because GHC is smart enough to write a functor instance for me. You can write something like... oh, we did that. Map +1 over a 5. That's what functor does. Pure is a way to lift something into a context. And app is kind of interesting. It's a way to take a 5 of functions and a 5 of values and apply them like pointwise to each other. It's more general than that, of course. It's not just about 5s, but for R5, that's what app does. And sequence A, for some kinds of combinations of data types, lets you flip something. So it's not as obvious if we're using 5, but it turns a list of 5s into a 5 of lists, or a 5 of maybes into a maybe of 5s. So that's a good example, actually. Let's look at doing that for maybe. So say we had a let f equal 5. We want a 5 of maybe in. 5 of just 1, just 2, just 3, just 4, just 5 in sequence A of f. And that turns our 5 of maybes into a maybe of 5s. And since they were all justs, we get just back. If any of them had been nothing, we would get a nothing back, because you can't get like an entire just of ints out of this. You can, because there would be a hole in it where that nothing was, and so it turns the whole thing into a hole. And so that's kind of what traversable lets you do. So let's write a parser, shall we? Why not? Import text regex applicative, and we'll just import the whole thing. If there's any conflict, so well. I'm a bad person. So in a recent episode, we revisited how the heck do you write a freaking parser. do I want to pre-process the input to remove like spaces, or like tokenize it or remove new lines or whatever? I don't think so. So my input is going to be two things. In fact, I think I will define a type input. Data input is an input of a list of int and a list of board of int, I guess. So we get two things in. We get the numbers that are going to be called and the boards that are going to be played on. And I don't think we're going to need any particular instances for this type. It doesn't look like it has very many interesting ones because it's not parametric and those usually don't. We can give it show or eq or whatever, but we don't really need that, I think. What are you warning about? Text regex duplicative. You're warning that it doesn't exist. Should be in my cabal file, no? It's right there. Is that not what it's... It's called text regex duplicative. What do you think my cabal file is? Stack GHCI. So it won't build, but yeah. Import text regex duplicative. Yeah, it's there. So if I like Emacs this, are you gonna work this time? Oh, maybe the problem is that I'm in interactive Haskell mode instead of HLS mode. When I'm changing what produces my build errors. It seems like it's happy about text regex. No? All right, screw you, Emacs. I hate all text editors. I'm opening VS Code. So let's open a folder here. This one. The shortcut that I had to open VS Code, to show VS Code to OBS isn't. Why not? How do I even VS Code? Properties. Oh, it was like aiming at date. What? Same window of type, you would think it would have matched. Window of same executable? Okay, I don't know. Anyway, here we are. And it's going to take forever to load, but eventually we'll hopefully have a functional editor that understands what we're doing. Oh, and I bet it'll even be able to tell me what types are in text regex duplicative. But I'm going to go look at GitHub for a sec. Let's look at when I did day 2 with a regex. How exactly do I do that again? I forget the names of the functions in the regex package. So, I mean, basically it's just this, I guess, right? And this whole structure of traverse, matching R, and lines, and from maybe input is like maybe not actually going to apply here. Because we don't kind of have a way to make an empty input. But let's, I mean, equal tilde is kind of the main thing we need. So let's write this in parts. And also show me the output so I can tell how close it is to being ready to use. Who knows what it's doing? Booting up the HIE BIOS. So let's write numbers is a regex. Let's say type regex a is an re char a. It's a regex that parses strings and produces an A. And then we'll say that numbers is a regex of list of int. Numbers is map read over something. Tokens? I don't know. Is it actually done? It is. So it knows what all this stuff is. And it knows we're using RE from text regex applicative. Okay. You go away for now. And so can you. We want like we kind of have to write our own set by, don't we? Set by sim. No, set by should take its arguments in the other order. Many int set by sim comma. We have to write int, we have to write set by. No, not many int, just int. There'll be ints separated by commas. That's what we're parsing here. Int is just... Oh, actually, I don't have to map read at all, because it'll be... int will do it. Int, then, is a regex for int, and int is read over many decimal from the module I'm using, please. Now, just to be clear, set by does not exist where I want it to in regex applicative. No. So let's define it. Set by takes a regex of A and a regex of B and produces a regex of list of A. Toke, well, they would call it P, right? P set by delim is P. Well, I guess it's more like cons of P applied to many delim P? That type check? Seems good. How would I know if it didn't type check? I'm not getting any squigglies. So let's test that at least. Jimmy, how do I view a terminal? Or a G8, okay, terminal view terminal. And if I say stack GHCI, it'll like have to recompile everything, which is, oh, and it won't work because I have lines. Where is undefined? There you go. Try again. No instance for num char arising from a use of decimal. Shouldn't many decimal... What is the type of many decimal? Will you tell me that if I highlight it? No. This should be a parser of... So many takes, in our case, a regex of char and produces a regex of string. Read mapped over that should turn the regex of string into a regex of int. So what have I done wrong? Decimal is an RE of char A. Oh, wait. Oh, where A is some number. Oh, I keep forgetting. Int, it's already defined. It's not just a... Okay. It's a decimal. Okay. It's not a parser for a single character. It's a parser for an integer. It's just decimals separated by sim. Okay, so let's move set by up. So we're going to need it again. And nice. Let's test this. Text regex applicative dot equal tilde. So what the heck order does that thing take its arguments? Takes the regex on the right. Really? Okay. So if we said 1, 2, 3, 15, 90 on numbers, we get adjust and it parsed out the numbers. Great. That's what we wanted. And out of curiosity, if we like give it extra junk at the end, it says no. So there's a different parser you can, a different parse application thing you can say to like parse as far as you can and give me what's left, but okay. We have our parser for numbers now. And our input contains these numbers and then a blank line and then many boards, where a board is a blank line followed by this array of numbers. Now, how do you say you want to replicate something 5 times in applicative language? Is that a thing that exists? Probably it would be an applicative? S times? M times? Maybe M times. Is that thing a monoid? Not really. Haskell parser repeat fixed number of times. How do I combine parsers up to n times? Obviously I can write it myself. I want to know if it exists. With an upper limit. Okay, they're just saying write it yourself. Fine. So let's then write n times as a function from int to, well, actually, since we're using 5s, and 5 is the only n we'll use, let's write a function called 5, which takes a regex of a and produces a regex of 5 of a. Right? Wait, actually it's not as bad as I thought. 5 of p is 5 mapped over p oh, but I don't want 5. I need a divider, right? I have this set by that I wrote for numbers, and I was planning to use it for my 5s, but actually I'm not going to. So 5 set by then takes regex of a and a regex of b, p, and then we'll call this dp, and we'll just paste this in 1, 2, 3, 4 times, where dp is delim p. This is going to have to be set by as well. So does that look okay? It compiles. Good. So can we say 5 sep by decimal and sim comma? Yes, we can. That's a way to parse exactly 5 numbers. Great. And we'll use it again to parse exactly 5 rows on a board. And so I guess we will therefore want a board function, which is a regex of board. And board is just sim of new line followed by what? Uh, 5 sep by row, and then another new line, right? Where row is 5 sep by decimal, many sim space, right? We do have to kind of map board over this, right? So is it really just, is it just this? Two more arguments to board. I never know how the parenthesization works. Is this the problem here or no? Expecting one more argument to board. How is that? Oh, a regex of board of int, I'm sorry. And this has to be sim of new. Okay, so that does compile. And I didn't need the parens, right? I could have written it like this. I guess I did need it. Okay, cool. Or maybe I could have written it here. I don't know. So we now have a parser for boards. It's a little tedious to test in THCI, but probably a good idea. 1, 2, 3, whatever, 10, 20. So if I said concat.replicate 5 applied to this, and I wanted to parse a board. You can't show it. Yes, fine. It doesn't parse. Okay, cool. So that's good to know. We messed it up somehow. Oh, we said it starts with a board, with an n, with a new line, not ends with. And that does parse. Cool. So we got out a board where there are 5 rows, and each row is 1, 2, 4, 10, 20. That's all I wanted to check. And I believe it also works if we put extra spaces in here, which the input does. Okay, good. So all that's left is a parser for inputs, right? Input is a regex of input. And input is just the real type, right? Yeah, it's input of numbers and then a new line. You know what? Let's just define new line. Can I like, can I say extract? Is that something you'll do for me? I guess not. Okay, whatever. I I guess my 5 set by is a little weird. I could have maybe, instead of handling the first new line specially, I could have handled it as part of the board. And then I could have 5 times a new line followed by a number or a row. That does seem kind of nicer. But I'll leave it alone for now. No, I won't. 5 times a row and a sim n. So we don't need 5 set by for anything else, so we'll just change this to be 5 times. We don't need the delim anymore. We just need a regex of a. And it's really just this. Right? Oh, I clicked in the wrong window. Okay, too many close parens. Yep. How about now? Part 1. Okay, I have too many close parens somewhere else. I didn't finish writing this. What now? Oh, I'm using 5 set by somewhere else. Oh, 5. Ah, I do need 5 set by because I'm using it here. I see. All right, I'll leave it alone. Regex heal yourself. Heal thyself? I forget. Thyself, right? Okay. Or are we back to a state that works? Except for the fact that this is not finished. Yes. And we can still parse. Okay, good. Input numbers, and then we have the sim new line, which I was going to pull out but didn't. And then many board, right? And does that compile okay? It does. So let's test this as well. Let b equal this. Why can I not edit that text? Oh, because it's right. It's a terminal, not a VS Code. Okay, whatever. I mean, let's just actually write this in a up here, right? Test input is a string. Test input equals let b equal this. In 1 to 10 plus new line plus b? I don't know. Is that at all reasonable, do you think? So let's then write input match test input. Couldn't match a type. Input is the regex that produces inputs. That makes sense. And input is my parser for inputs. Oh, I did get these flipped around, didn't I? No instance for show for input. Thought I had done that one. Okay. Reload. Okay, so it parsed. We got 1, 2, 10 are our inputs, and there's our... Wait a minute. There's only one board there. I thought I made 2. Nope, I just made 1. Okay. Okay, so let's say we made another. Now that doesn't parse. Yes, that makes sense, because there's a blank line between each board, and we never handle that. So what we should do, actually, is numbers, and then many of a new line preceding a board. Yes? Oh, that shouldn't be many anymore. And now it parses somewhere. There must be a comma here, right? A board with 5 things, and then a comma, and then another board. Okay, so our parser is finished. Let's just commit this. Where's my terminal? Oh, I don't need yesterday's thing. Git add dot git. Day 4 parser. And then clean up that garbage from yesterday. Okay. So, all right, we spent a lot of time parsing a fairly simple input format. Alternative many. Yeah, I mean, I guess we can just get that all from applicative. Fine. So we still have to do all this work of like actually playing bingo. And we haven't really written prepare yet, but that can come later. I'll glue the pieces together once I have part 1 done. Actually, it's easy. From just composed with equal tilde input. Please import this for me. This is cheating. We're asserting that it'll always parse, and if not, we'll get a runtime error. So part 1. I mean, I don't know. In some sense, we kind of want not really to have a list of int or a board of int anymore. We want a board of maybe int, right? So let's write a function that mark takes, given eq a, it takes a board of maybe a and produces a new board of maybe a. Mark x is just fmap erase x over the board, which will take an implicit parameter, where erase x of y if x equals y equals nothing. Oh, this is going to be typed wrong, right? If x is just y, then nothing. Otherwise equals... I think I'm doing this backwards, aren't I? Equals, what was there before? So does this type check at all? No. Oh, it's supposed to take an A as its first parameter, of course. Yes. Okay. That looks like it type checks. So we're gonna, when we get a number in, you know what? Let's just do it like that. Sure. So the idea is we're going to map over all the items in the board, and those will be maybes, where we'll be replacing them with nothing if they've been marked out. And if it finds a just 10 and it wants to erase 10, it replaces it with nothing. Otherwise, it leaves it. So that's cool. Now, what other functions do we need? We kind of want a function like isBoardWinner. So let's say winner is a function from board, really of any A, right? It doesn't even need to be eq to bool. And I guess winner of B is, first of all, I mean, we could say winning row. What is the type of any? Oh, it doesn't parse now because I'm not. Or it doesn't compile because I messed that up. Okay. Type any. It takes a foldable. That's good. We have a foldable. Our list of boards is foldable, right? Or our 5 of 5 of ints is foldable. So I think what we can do is actually kind of cool. We can say a board is a winner if any of its rows are all is nothing. You just import the whole module for me. Add is nothing. Yeah. So, but B, we do need a board of maybe A's, not just any A. And so this will tell us if there are wins on any row. So we can then say, or any all is nothing of sequence A, B. Ta-da! And we can take this. It's highlighted both of them. Kind of cool. But we can say, what's a good name for this? I don't know. I'll just leave it alone. So the idea is we look at all the rows and say, are any of them just completely marked out? Or if we traverse B, flipping it, kind of transposing it basically, are any of its rows, which are the columns of the original input, all marked out? So we have a way to mark a board with a number. We have a way to check whether a board has won, and so that seems like we must be practically there, right? Yeah. Right? So we need like find winning score, kind of, that takes an input and loops for a while. Let's just write that, and I'm sure there's some more elegant way to do it. Maybe it will come to me as I'm writing. So let's let's just call this draw, because you're drawing a number from the hat, sort of. Well, we have a list of boards. But that's fine. We can just map marking X over all the boards and then look for a winner, right? So, yeah, I think we can just write a function that takes an input and churns it for one step. Tell you what happened. Winning score takes an input and produces an int. This is actually just part one, now that I look at it. I'm sure some of what I need... In some sense, I expect that I'll need a lot of this for part two as well. Some mechanism for drawing numbers and marking the board, right? I don't know what I'll need for part two, but it seems like what might be nice is to have a list of all the states that a bingo game goes through, right? Maybe that's what we can write. States is a function from input to list of well, I guess we kind of want board of maybe int. Let's real quick data state is a state of last called, which is an int, and a list of board of maybe int. Our boards. Driving show. I'll probably want to look at these in the REPL at some point. So, this will produce a list of state. States of input of nums and boards equals go of nums and fmap just fmap just over boards. I have a list of boards. Finding for boards shadows. Oh, in the record thing. Yeah, okay. I'm just gonna like give these both underscores in front of them. I kind of hate record accessors most of the time. And this way, if I ever want to drive lens, there it'll be. So, okay. Where go of empty list and any set of boards equals actually it's like we'll just say it equals nothing, right? That's probably okay. I'm a little bit concerned about where I'm gonna get the last called number from. But okay, go of n's and boards is a new state containing, I guess I could have my state contain the list of numbers that are yet to be called, but I'm not going to. There's a state containing n, the last thing called, and fmap mark n over boards. Cons to go n's boards. No, hang on. That type checks, but it's not what I wanted. Because I need this to be a variable that I'm going to reuse. Boards prime, go n boards prime, where boards prime equals this. And then I can write it much more nicely as well, like that. So I think this should give us all the states that a bingo game goes through. Let's open up the terminal again. And I have this input now, which is, it has 1, 2, and 10, and then it has some boards. So suppose that I took that, and I said, what are the states derived from running that? Please reload. An input and a maybe input. Oh, yeah, right. Because test input, okay. It doesn't. Yeah, let's say instead we've written a bit more now. Let's just say prepare of test input. And it ran. We got some outputs. Were they correct? I don't know. It just called 1, and all the boards suddenly have a nothing in their top left corner, right? And then in the next step, well, eventually just called a 10. There's still nothing in the first corner and nothing here. Yeah, this looked like that worked. So part 1 then is going to step through the states of the states produced by the input, looking for a state in which a board has become fully marked off, right? And then compute the score of that board, or of that state. So let's write a function, maybe find winner. First, sure, find winner takes a list of state and produces a state. No. It produces a tuple, let's say, of int, which is the last number called, and board. Find winner. I can't, that's an impossible, I can't make that promise because there might be no winners in the state. Okay, let's just write part 1 and have it do all the work. Part 1 of, I wonder if actually it would make more sense for our input to just be a list of states, but whatever, we can call states on the input. Part 1 of I is go of states. And we're going to produce an int here eventually. Go on states of I. I guess in that case, go is just, part 1 is just go composed with states, where go is a function from, well, whatever. I hate go. I don't want to write recursively. I want to write a filter and just assert that there's at least one thing in it, right? But no, I kind of, I don't want a filter because I want to like, okay. Go of, we'll just leave it. We just won't even mention. Go of S's, equals case. What is our state type? State of last called and board. Okay, so we actually want state and B's, cons to S's. Case filter winner B's? Is that right? Yeah. Of. I will not That's kind of cool that Wingman is actually doing something useful. It's saying, well, I mean, I don't know. Try it. What do I get? Okay, that's not bad. Good work, Wingman. So if there were no winners, then it's just go S's. Continue onwards to the remaining states. Otherwise, we're going to ignore the remaining boards. By the way, is it calling BOs? I don't know. It's weird. And it's just going to be, I think, n times. So I have a single board. So I guess I should destructure that. Board B. N times, and B is now a 5 of 5 of int, right? So I can just say sum B. And you're warning me, of course, that the pattern matches are non-exhaustive, which is true. I'm not handling this. So why don't you just like fix that for me? You can't do that. Well, okay, whatever. I'll just do it so the warning goes away. Fine, you got me, compiler. Go of emptiness equals error, no winner. Night Mark. Sum B doesn't quite type check because I thought of this earlier, but then thought it wasn't going to happen, but it did. We don't have a list. We don't have a 5 of 5 of int. We have a 5 of 5 of maybe int. So there should be some function that we'll say sum.toList filter is just toList. B, wrap this in parens. So import these for me is just, oh my god, data foldable toList. If I call toList of B, oh, the problem is that B is a 5, not a 5 of 5. I've thrown away the useful new type wrapper I had a minute ago by unwrapping the board. Haven't I? Yeah, my board, I want to map over the board before I destructure it. So let's say BBs. Turned into a bit more of a nuisance than I had hoped. So the board is a foldable, right? Tell me I made board foldable. I didn't. Okay, but I can. So now if we call toList on the board, we get at the list of maybe A's, right? Board of, I do have a board of A, yeah, okay, that's all right. Filter is just, oh, now I can just say cat maybes, now that I have things ordered properly. Yeah. Right? So we convert the board to just a list of maybe ints, we throw out the nothings, and we add them together. And we multiply by the last called number. So let's give it a try. Stack. Oh, I don't even have my input file yet, do I? Oh, this won't this won't parse because there's a new line at the end of the file which I didn't account for in my parser. I was very, it's okay. Just end the file there. So stack run. I bet I get 0 or something, or a nothing. It would fail to parse. Error. From just. Yeah, so it didn't parse. Ugh. I assume, anyways, what happened there, because I think it's my only from just call, right? Yeah. Go ahead and fix my imports for me. Thank you. Problem is I don't really know how to debug things in Haskell. I always make a big mess of it. For some reason, one of these boards like didn't parse, or the whole thing didn't parse. Oh, maybe there is supposed to be a new line at the end. What does my board parser look like? Where's the regex for boards? So I'm saying it starts with a new line, and then there's new line separated thing. So it shouldn't end with one, apparently. And indeed, my test input doesn't either. And my input parser? Many times, a new line followed by a board. And my test input is 1, 2, 10, a new line, and then this board several times, which is new line. So there should be one blank line between the input numbers and the input. And then another new line between them, right? Oh, wait a minute. Ah, no, each line of the board starts with a new line. So this all seems fine, but I'm not 100% sure I'm actually correct. And it doesn't parse, so that's good evidence that I'm not. So 1, 2, 10, then a single new line. Okay. Then a B, which is a single new line, and then a 1. So single new line ending numbers, single new line here, okay. And then a B is this. Well, it's this, and this, and this, and this. And this is the end of the first B. And then I say another new line. That's this. Followed by B, which is a new line followed by 5 things. So it seems like my test input about matches what the input is supposed to be. Let's just try, though. Many psim is space. And we'll just throw away any trailing spaces, just in case. I don't think there are any. Variable not in scope psim. Oh. Yeah, from just. It failed to parse. Why would you fail to parse? How dare you? How can I reproduce this error in a way that allows me to debug it? Because I was careful as I was writing my parser to test it on reasonable sized, on inputs, right? But I guess I didn't test it on like the input from website. Where the hell is my browser? Here it is. They have this very simple thing. It was like, I'm looking at this and it's exactly the same like as our input base. This isn't a useful test case for me. Double check we're reading input, yes. Well, okay, I mean, let's say read file input.txt, make sure this looks okay. And indeed, it doesn't end with a new line, as we sort of expect. Oh, you know what? I bet the way I handle rows is incorrect. Yeah, look at this. I forgot that there can be leading spaces at the beginning of a row. I'm throwing away spaces in between. So, in fact, both places where I used 5 set by, I should have used like 5 times, I think. Yeah. So let's replace 5 set by with 5 times again. Make sure there's not another use I'm missing. No. Okay. Let's write 5 times. 5 times, and we can throw away this b parameter. And this delim. And this. Everything just gets way simpler. Oh, these all should have been p, not d, huh? And so what we want really is 5 times of that. And here again, 5 times some number of these things, of spaces, and then a decimal. We can even do this like that. There you go. So, does that look any better? I guess I could have tested my belief by asserting that it doesn't work on a... that it didn't work on a row with empty... with spaces at the beginning, but I'm pretty sure that would have been the case. Okay, back to the terminal here. If I say stack run, are you happier now? Hey, it's a number. Okay. Is that a plausible number? It looks a little large, doesn't it? How is this number defined? The sum of the remaining unmarked numbers times the number that was called. I mean, okay. It's 10 times as large as the test input, but like, there's a lot, there's some big numbers on these boards. I could believe it. And there's a lot of boards, so one of them will win early and have a lot of numbers. Okay, let's try this. That's the right answer. Oh, thank God. All right, I'm always relieved when I find this. So get status, get... I thought I got rid of... Oh, all right. Whatever. Could add -p, I guess? Is there anything I don't want to add here? Add that. Yes, I want that. Ooh, my winner function has an extra space at the... That's what I get for editing in anything but email, huh? Don't add that yet. Okay, and then go ahead and add that, and add the input as well. Git commit -m day 4 part 1. All right. I mean, I'm not unhappy with how that turned out, to be honest. It was a bit messy in the middle, and I don't know. The parser, the regex was more work than I had hoped it would be. But we wound up with a very nice, clean data model, which is the kind of thing that I like the most, I think. Which is that we have like a board which is guaranteed to be 5 by 5, right? How many people do you think are solving advent of code who are making sure that their board is exactly 5 by 5 at the type level? Probably not very many, right? I would bet more than one, because there are some Haskellers out there. But even a lot of Haskellers will be more interested in just like expediency for a small programming puzzle like advent of code, and will work with a list or an array or something. I did my own sort of corner cutting in places, like, I have this call to error, I have from just, it's not perfect. But it's fairly well statically typed, I think. And I do always like to proselytize for Haskell's parsers and regex support. In a sense, like, I don't know, what I wrote is... Oh, we could have gotten rid of it, couldn't we? What I wrote is a lot more text than somebody who was solving this in another language, right? This is my regex, right? It's 16 lines of like parsing code in quote, which seems like a lot of work. But, 1, 2, 3, 4, like actual lines. The rest is just blanks and types, right? And you can write in, for example, Python, a regex that parses line 1, but you can't, like, as you're writing that regex, get the values out of it. What you're going to get out is, like, well, I guess, right, you're going to call splitter. You're going to call split on comma, and it'll give you back, like, a list of string, and then you'll read each string. I don't know. Maybe it's not. Maybe what I did isn't so cool. But I just like that, regex libraries in most languages give you back a bunch of, like, strings where you have matching groups on. Whereas with Haskell, note I never got back a type that wasn't what I wanted. Right? When you're parsing in the applicative style, you're actually producing values at the same time that you're parsing the input format. And so you don't have to, like, first run a regex, get out a list of groups, parse each group as a string or whatever, or into an int or whatever you're supposed to do with it. When you're done parsing, you already have a value of the right type. So, okay. I mean, my solution is not amazing or anything, but it's fine. So let's get back to part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards the giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. No matter which board it picks, it will win for sure. Figure out which board will win last, what would its final score be? Okay, great. So the fact that we wrote this states... I was going to say, get out of here, input, is, oh, isn't it nice that we just wrote states? Because, yes, we do want to run through all the states that it's going to be in, but we don't want to just keep going until there's only one board left. Because there might be some boards that will never win. Actually, will there? No, of course there won't. Because if there were such a board, then the squid could pick it, and it would win. It would, like, not win. So the board that wins last. Okay, that's fine. So let's write part 2. Which is basically just going to be most of part 1, really. Sadly. We need a different termination condition. We want to say if there's only one board, one state left, state n b, we're gonna do something. And winner B. That's important. So if there's only one board left, I have too many closed brackets. If there's only one board left, and B cons onto more states, cons onto anything. So if if we're at a state where there's only one board left and that board is a winner, then we're just going to write n times, well, now that we know we need the score function, I'll extract that from part 1. Score takes an int and a board and returns an int. Score, God, it keeps putting spaces there. Score NB equals this. Score NB. Score NB. This isn't a board. Oh, a board of, this doesn't need parents. Maybe int, right? We could even maybe say num a. This could be more general, right? It could score boards of maybe floats as well. Isn't that nice? So part 2, we're just going to say score NB. No, wait. We already did that. That's here. And otherwise, for any S's is go S's. And go of nothing is error, no winner, I guess. Right? How does that look? Does it compile? I don't know. I think so. Stack run me. Error. Error in main. No winner. In main at line 70. So it got here, actually. That's a little weird, isn't it? How did that happen? We got all the states. And if we ever found a state where there was only one board and that board was a winner, we would score it. And otherwise, we just recur and look at the rest of the states. But somehow we wound up with no winner. Hello, Daniel. Welcome to Haskell. We're just finishing up part 2 here, which really ought to be the same as part 1, with a different termination condition. But when I ran it a minute ago, it said that it got to a state where it had gone through all the states and never found us in this state. Found it to be the case that there was only one board left and that board was a winner. Why? I mean, how do we even debug that? I guess the obvious answer is to just look at all the states and try to detect the one where there's only one board left and that board was a winner. Well, Daniel asks, why do I get the feeling that this language is smarter than, for example, Java? I will draw your attention to one thing that I thought was kind of cool that most people in Advent of Code won't be doing. That the type I'm using for boards that I defined here is guaranteed to be 5x5 statically, right? Instead of using a list, which is arbitrary length, and then handling a list of lists or an array or whatever, I said if you have to have 5 of something is to like have 5 of them, and a board is 5 fives of ints basically. There are definitely exactly 25, which is kind of nice, and you get all these cool like type class instances for such a type as well. So it can interact with built-in Haskell functions like sequence A. I don't have to write transpose myself, for example. Now, one thing we might wonder is, did I, for example, fail to handle... Oh yeah, also this is... Did I fail to handle, like, winners on columns or something? And I think probably not. Like, part 1 would have been the case. So let's maybe grab the test input from Advent of Code and run that. It's a much shorter input that we can work with. So test input dot text. I wasn't supposed to put a trailing new line in there. Okay. Oh, but if I edit it in Emacs, it'll go in, won't it? All right. Okay, so that's my input. Actually, I guess I wrote some code to strip the trailing inputs, so whatever, it would have been fine. So what I want to do is I guess I want to be back here, don't I? Stack GHCI. So what are the states of prepare, no, read file test, what did I call it? Test dash input? Yes. Input.text, pipe to, states composed with prepare f mapped over this. Okay, great. So I got a giant slew of text. But at some point, when should the game have been won by the squid, according to Advent of Code? The second board is the last to win, which happens after 13 is called. Oh my god, this is illegible. When is 13 called? I don't know. About halfway through. I see a 13 here. Just keep looking until the last time you see a 13, and that'll be when 13 was called, right? That's last called equals 6, which is right after 13. Okay, we're getting somewhere. So find the first state. Oh, did I forget to throw away the winning boards? Ah. That's what happened. So when a board wins, I should throw it away. It didn't matter for part 1, because as soon as a board won, I was finished, right? But once a board wins, we should stop marking numbers for it and just throw it out. So let's say go ends boards, but what we'll do is filter first, not winner from the boards. We'll throw away all the winners. So throw away the winners from the boards we're still looking at. Yes, very good. I think that will be the problem, or will have been the problem. Stack, oops, get me out of GHCI. Stack run. Okay, a number. And it's a smaller number than the first one, which is about what we would expect, because there should be more numbers marked off, and therefore the sum of the remaining numbers should be smaller. Hey, okay, we did it. So get let's just open the file in Emacs and then close it again, because that'll fix all the white space errors that VS Code put in. Okay, git add p. So what do I want to add? First of all, let's add this and git commit amend no edit to just like not include that text input in part 1. Okay, great. Now git add dash p. You guys are seeing this, right? No, sorry. I just took this and said, please uncommit it to yes to part 1's solution. Okay, and now we're looking at the rest of the input, the rest of our changes. And yeah, I think that's all that part 2 was. Git commit dash m day for part 2. Git log, make sure I got that right. Yeah, parser part 1, part 2. I can never, by the way, I'm not consistent at all about whether I'm using commas or colons for my day, you know. I think actually I am kind of consistent in a weird way, which is that when I'm writing day n part 1 or 2, I use a comma. When I'm writing anything else, like some refactoring or preparation, I always seem to use a colon. I don't really know why. I think it would be nice to be consistent, but I guess this isn't so bad either. So maybe let's go back over the solution real quick before we go, see if there were any interesting points to reinforce. Well, I mentioned before a couple times that I thought it was cool to actually have a type that is guaranteed to have exactly 5 items in it. This is, of course, very easy to do in every other language, right? You could define, well, you know, in Python, you could make a class that has a constructor that takes 5 arguments and assigns each of them to self.a, self.b, self.c, self.d, self.e, and so on. You could do that in Java, an object with 5, or a class with 5 fields. You know, anybody can do this, but nobody else ever does. I'm sure there are languages that are even more like, you know, BDSM than Haskell is. Like, I'm sure people writing in Coq or Agda or whatever would do something like this, but I don't know them, so. But it's really, like, in Haskell, it's very easy to define a type that has 5 elements. This is just one line. And you know, we get for free stuff like, you know, give me back a list of those items by implementing foldable. We get for free stuff like, let me modify each element by using functor. We get for free like a printable thing, which I think, you know, for example, Python has with repr or something like that, probably, right? But we can participate in, like, you know, we can sum up the elements using foldable. And I added applicative and traversable instances to let me do even more. I think the only thing I used for this was transpose, or I used this for was transpose, basically, which is too bad. You know, it would have been faster to just write transpose once. Maybe? It would have been close. I would have written 5 constructors, and the number of tokens I would have written is 25, and that's about what I wrote here. So it comes out about the same. But instead of just getting transpose, we get a ton of other stuff that we can do with 5s. We ended up not doing any of it, but that's life. And our board type, containing a 5 sets of 5 x's, or a's in this case, is guaranteed to have exactly 25 things, which is nice. Our state function, our state type and input type are kind of boring. This regex, I talked some about how, you know, this doesn't look anything like a regex in most other languages, but, you know, it's a regular expression parser that is not based on, you know, some library that parses a string for you and produces a black box that does magic, right? Instead, it's a combinator library where you can combine regexes, small regexes, into big regexes and produce meaningful output rather than just like blobs of strings, which is what you get out of the regex libraries in most. And so we wrote a parser that takes a string and produces an input if that string is of the format we expected and produces nothing otherwise. Mark was a function that benefited from us writing a functor instance for our type. Of course, if we'd used like a list of lists, it would not have been so hard to write mark either. But we were just able to map a function over the whole board, and it knows, because of what the type parameter is, that means find all of the maybe A's on the board and map something over them. Basically turning any numbers which match the input turn into nothing, and everything else is left alone. Winner is kind of cool. We got to fold over our board using any and all. So any here is mapping over the rows of the board, and then all is saying, are all of the items on this row nothing? If so, the board was a winner. Or maybe we'll try sequence A, i.e. transpose rather, the board. And then if any is mapping over the columns, and it's saying, are all the things in this column nothing? If so, then the board was a winner. So that's kind of cool. States, I think, was a good idea. Rather than having part one, play through the board and produce just an int, we first said, let's produce a list of all the states the board has ever been in. And that way part one and part two could both make use of that and just walk through all the states that existed rather than having to re-implement the machine themselves. Haper asks, did day 4 give you a headache? I mean, kind of. My regex ended up being a little bit more work than I would have liked, and I had to fix a couple of bugs in it because it is like fairly low level. I would have liked to do that better. And I spent a lot of time on this like 5 type. Not all that much time, but just thinking about it. And I was okay with that because I can't remember writing a traversable instance. I just don't do that very often. But here it seemed like something I would want. And I was like, thinking about, can you traverse a 5? If you have a 5 of f of a and f is applicative, can you traverse this thing? And I was like, I don't know. But yes, of course you can. For the same reason that zip list is traversable, 5 must be traversable in the same way. And that's what we have here, right? Our 5 is just a zip list constrained to have exactly 5 items. And so it was kind of cool to do that. Part 1 did give me the correct answer the first time I tried to run it, which was nice. Part 2, I had made a mistake in states because I didn't throw away winning boards. Well, not a mistake. It might have been good to continue with leaving all the winning boards in. I didn't know until I got to part 2 what I was gonna want to do with boards that had won. And I'm a little bit annoyed about the number of times I wrote error or from just or something, because this is ways where my program could crash instead of doing what it claims it's going to do. I'm usually not too bothered about it in Advent of Code because their input is guaranteed to be correct, but Paper says, in part 2, the assert, for example, passed, but the answer is wrong for me. Not totally sure what that means. I'm guessing it worked on the test input but not the real input? I don't know. Yeah, I mean, I think we kind of talked through everything there is in this program. Regexes are cool. Well, parsers, really. Combinator libraries are cool. And having one for regexes is nice. Modeling your data type, making illegal states unrepresentable, right, is a thing that Haskell is into, and we've done that here by having our board be a 5 of 5 of A instead of just be a list of A. So I think I'm pretty much done here. Took longer than I would have liked. But that's what they tend to do on the weekends. Also, I did it slowly. I did it in what seemed to me like a fairly principled way instead of a slapdash way, and it still took me some time, but I'm happy with what came out in the end. I'm going to end the broadcast in a minute once people have finished getting their goodbyes out in the chat or what have you. Thanks for watching, and I'll see you next time.